Alright, we're looking at page 489 and we're looking at problem number 12. Problem number 12. Let me read this to you. Spike it. Marta hits a volleyball so that it strikes the ground 15 feet away from her. If her hand was 9 feet off the ground when she hit the ball and the wall is 54 feet from where the ball hit the ground, use similar triangles to find out how high up on the wall the ball was hit. Explain why the triangles you worked with are similar. Alright, so let's looking at the given. First off, we have the distance from Martha to the ground where the ball hits, or which the ball hits. That's 15 feet. So from this point right here to this point here is 15 feet. Okay? Alright. Distance from Martha's hand to the ground is 9 feet. Okay? Distance from ground where the ball hit to the wall is 54 feet. And we're supposed to find the height of the point on the wall where the ball hits. That's this point right here, and we're going to call that x. So, the fact that the ball hits and bounces back is these angles are congruent. They're similar because they're symmetrical. Whenever you have a reflection, the angles are congruent. So, all right. So if these angles are the same measure here and here, and we know that these angles right here are both 90 right here, that means that these angles, the remaining angles, which are here and here, also have to be the same. So if we have corresponding angles are congruent, then we know the triangles are similar. So with that information now, we can set up a ratio. So we can go the height of the ball to in relation to the distance from where the ball is hit to the ground that it strikes, 9 is to 15, as x is to 54. So we can now cross multiply, so we're going to go 15 times x. 15 times x is equal to 9 times 54. So if we do the multiplication, 9 times 54, we get 486. So I'm going 15x is equal to 486. And now all I need to do is to divide both sides by 15, the number that is multiplying x. So we divide both sides of the equation by 15. And we come up with x being 32.4. So x is 32.4 feet. Okay? Alright, so that's A. And B, do you think your answer in A tells you exactly where the ball is hit? Is it a good approximation or is it a poor approximation? If it is an approximation, do you think it is an overestimate or underestimate? And explain. Well, I think the things that would cause this to not be exact are the fact that we have friction. So this is part B. So you have friction and you have gravity that keeps the physics from being absolutely true on this reflection. So, and if anything, those things are going to dampen, the bounce, which will cause this to probably be an overestimate. The fact that you have gravity and friction working against the ball would probably cause the ball to be somewhere down in here. Okay? That would be my answer for part B.